study of this topic, gravitation, was done by Newton. Okay. Even before Newton gave his laws of gravity or universal law of gravitation, gravity was acting. Okay. Many people was aware about gravitation, but they were not able to find out that what is the reason. Point number one, how it changes, like what is the formula, how this formula will vary, and all these things were not known, and all these were structurally developed by Newton. That's why his contribution is immense in physics and for science and for humanity. Okay, so what this law of gravitation says, please pay attention. According to this law, according to universal law of gravitation, according to universal law of gravitation, every massive object, every massive object attracts another massive object, another massive object by virtue of their mass. Okay. Basically, what this law says, that in the universe which we are living, every object which has mass can attract another object which has mass due to their masses. Okay. So mass is the key responsible factor for this force. What is the deciding factor for this force? Mass. Okay. All right. So suppose if there are two particles, one is m1 and other one is m2, and if separation between them is r, then F is proportional to m1 into m2. That means force between the two objects is proportional to product of their masses. F is proportional to 1 upon r square. That means force between the two masses is inversely proportional to the square of distance between the two objects. Okay. If we club these two, then we get F is proportional to m1 m2 upon r square, and when we remove the proportionality, we get F is equal to g m1 m2 upon r square. We get F is equal to g m1 m2 upon r square. Okay, here g is universal gravitational constant. Okay, and value of g is 6.67 into 10 to the power minus 11 Newton meter square upon kg square. Okay, why it is called universal gravitational constant? Because it remains same throughout the universe. Wherever you go, value of g will remain the same. Wherever you go, the value of g will remain same. Okay, that's why it is universal gravitational constant. That's why we are calling it universal constant. All right, all right. So let us move further. Before we actually write points related to this, let us do one simple question. One simple question. And the question is, if two objects of mass 50 kg are kept at 1 meter separation. If two objects of mass 50 kg are kept at 1 meter separation, find gravitational force. Find gravitational force acting between them. Find gravitational force acting between them. Okay, please find. All right. So F is equal to G m1 m2 upon r square. G is 6.67 into 10 to the power minus 11 into 50 upon 1 square, and that force comes out to be 1.6675 into 10 to the power minus 7 newtons. Now this force F is actually 1.6675 upon 1, 2, 3, 4, 5, 6, 7. It is that small force. It is that small force. Now, because of this force, everyone please pay attention. Because of this less force, you don't feel attraction towards another massive object, because I am assuming your mass is approximately 50 to 60 kg, right? So basically, we don't see effect of gravity that much in small objects. For small objects, we don't see effect of gravitational force that much. Why? because even if the wall is, let's say, mass of 200 300 kg, I'm talking about wall, the force is very less. You don't feel pulled towards wall, and walls are on both sides. Okay, so even if the small force is there, that is cancelled. But this force becomes significant when one object is earth. When one object is very heavy, then this force becomes very significant. Okay, let me give you another question today. So this is m is equal to 6 into 10 to the power 24 kg. Radius is 6400 kilometers, and then there is a person of mass 50 kg. Let me call this as A and this as B. Question says find gravitational force. Find gravitational force acting between A and B. So what you need to do is you need to find gravitational force acting between A and B. Please find. Okay, everyone, please pay attention. So F will be G m1 m2 upon r square. G is 6.67 into 10 to the power minus 11 into 6 into 10 to the power 24 into 50 upon 6400. But remember, this is in kilometers. So into 10 to the power 3 and whole square of that. See, height of that person will be very less as compared to 6400 kilometers, right? So when you are going to solve this comes out to be approximately 478, 488 newtons. Okay, and you could have solved this question directly by F is equal to mg. M into G is 9.8, M is 50. So 50 into 9.8, and that becomes 490 Newton. So you could have solved it that way also. You could have solved it that way also. Okay, good, good. Next question. This is 2m, this is m, and this is 3m. This is A, this is A. Question is find net force. Find net force acting on small m. Find net force acting on small m. Very nice, was very nice. Presley is saying gm square upon a square. Gauri is saying m square g upon a square. Sandesh is saying 5gm square upon a square. Mayank is saying 5gm square upon a square. Suhas is saying this very nice means I am wrong. Okay, pay attention. See, gravitational force is attractive force. Okay. So force due to two masses will be in opposite direction. This is F1 and this is F2. So F net is equal to F1 minus F2. Okay. And that will be because of their opposite directions, mind it. That means G into 3m square upon A square minus J into 2m square upon A square. And that becomes gm square upon a square, and direction will be towards right. F net, F net. Okay. That is the answer. That is the answer. Can you find net force on 3m? Find net force on 3m. Please find, everyone. Find net force on 3m. Please find. Very nice, Mayank, very nice. Pay attention. F net due to this and due to this, right? So F net will be Gm into 3m upon a square plus G into 2m into 3m upon 2a whole square. Barobar. And that will be 3gm upon a square plus 3 into 2 is 6 g m square upon a 4a square. So 3 plus 3 by 2 will be 9 by 2 g m square upon a square. That is the answer today. Very nice, Mayank, very nice. Okay. So that is enough for today. We'll study further in the next class. No problem, man. Keep working hard. Hard work is the key. Efforts, your efforts are going to lead you to the output. Okay. We are not playing a T20 match. We are playing a test series. All right. Okay. Bye bye. Thank you so much.